Hey guys, welcome to another video of your favorite cloud learning platform, K21Academy, where you learn cloud from the experts. In this video, our expert trainer will be talking about enabling team-based data science with Azure Databricks. We have taken this clip from our step-by-step learning program on data engineering on Microsoft Azure DP-203. Guys, make sure you watch the entire video so you can avail the free gift at the very end. Now, let's hear from our expert.
Hey guys, how are you? Welcome back. Let's start with the module number 3. In this module, we'll talk about Databricks, and the topic is basically enabling team-based data science with Azure Databricks. So we'll be talking about various type of. So basically, first of all, we'll talk about what is Databricks, and then we'll talk about how do we provision Databricks, what's the meaning of workspace, how do we read data, and how do we do transformations with Databricks. So let's get started. The very first thing is, what is Databricks? Like, that question should come to your mind. So that's the first thing we'll answer. And then what is Spark based? What is Spark? How Databricks integrate with the enterprise security? How Databricks integrates with which other services on Azure platform? So let's get started. Now, very first thing is, what is Azure Databricks? In a nutshell, it is Spark cluster. And Azure Databricks or Databricks Spark cluster is 10 times faster than vanilla Spark and simplifies the. So what is Databricks? It's a third-party company. They did a tie-up with Azure. Now it's called as Azure Databricks. It's a zero management Spark solution, meaning from the point of view of cluster management, everything is taken care by the platform itself, and you just have to create your code or the jobs and you run those jobs in the cluster over there. So simplifies the provisioning and collaboration of Spark-based analytical solution, and it utilizes the capability of Azure Active Directory or role-based access control to provide enterprise-grade security. We can integrate various Azure Data Platform solutions and Power BI as well with Azure Databricks to create the end-to-end solution. So what is Apache Spark? Apache Spark is basically parallel processing framework that supports in RAM or in-memory processing. And it really is around 100 times faster than normal Hadoop processing. And it is used for real-time processing. Whenever you have huge amount of data, you want to also transform data into real time. Maybe data is coming from point of sale devices and you want to detect fraud on the data in real time. So data might be hitting the Kafka cluster, which will act like the ingestion layer. And then from that, data will go into Spark cluster, where we will run some fraud analytics job and we'll flag it. We'll say whether this credit card transaction or that transaction which is going on in this real time is fraud or not fraud, like that. So real-time transaction, whenever we don't have much time at hand, maybe a couple of seconds with us, then we go for Spark. And in Azure, Spark is literally one of the go-to solutions for Spark is called as Databricks. And it's not the only solution. In Azure, Spark can also be created with the help of Azure HD Insight. But HD Insight is not really zero management. It's more raw versus Databricks. So Databricks is one of the go-to solutions. So what does Spark provides? It provides analytical in-memory parallel processing, where we process big amount of data and we work with massive volume of data. So we can do interactive data analysis. There will be Databricks notebook will be available. It's very similar to Jupyter notebooks, and we can basically see the visualizations along with in the same code notebook. The HTML visualizations or annotation can also be done. Stream analytics can be done, meaning data is getting streamed, hitting Kafka, and then it is being transformed in real time. Machine learning can be done, and Azure Databricks provides the GUI Spark cluster. In the lab, I will show it to you, right? We'll create a Databricks cluster, we'll have a look at it. And there are multiple core components of Databricks. We're not concerned about all of them right now, but we have basically data frames. Data frames are equal to Pandas data frame, where we load data. Spark SQL is basically SQL on Spark. And streaming is used whenever we work with stream of data, and we transform or we process that stream of data in real time. That's when the Spark streaming comes into picture. MLlib is basically machine learning part of it. GraphX will provide me with graph functionalities, and Spark Core API provides everything as such. For example, so if somebody asks you that what is the basic thing which I require if I want to write any job in Spark, in SQL or maybe Python or Scala language, then you might say that Spark SQL core, so Spark Core API will be required for that, the last option over there. Now, as we were just talking about, the Databricks connects with the Azure Active Directory. We have specific role-based access control rights are there in Active Directory, which can be assigned to users working in Spark with Databricks. So it provides those. See, role-based access control is one of the most important thing for working on premises or in cloud as well. Without giving rights to people based on their job profile, it will not be possible for us to work. We provide limited access to people, so they should not be able to do or the surface area of attack should be as less as possible. So if you give limited access, as per the job profile, if the user needs read access, we only give read access. We don't give write access. So all of that is possible only because of Azure Active Directory and the role-based access control mechanism which is there. Enterprise service level agreements are available. Multiple type of them are there, and based on the cost, the SLA changes, and we can select the one which is more suitable for us. Now, when we talk about integration, it integrates with every Azure service as such: Data Lake, Cosmos DB, Data Factory, Power BI, Synapse, Blob, Cognitive Services. And the core service which we will be concerned about or from where we'll read and write will be Data Lake. Data Lake is Hadoop distributed file system. So you can say Spark is the big data tool over there, and the storage layer we are going to use will be Data Lake. So if we answer these questions, check this out. Azure Databricks encapsulate which Apache technology? Answer will be Spark. Which security feature does Azure Databricks not support? This is FYI. Shared access keys concept is not there. For example, shared access signature means that I have a, you can say, so we signed one token, and with the token, we can access for some point in time. Those type of concept is not there. It's not even required for Databricks to have that concept. So shared access signature, shared access key concept is not there. Our token concept is still there. You can give access to people with the help of tokens as such. Which of the following Azure Databricks is for support of using Spark Core API? We can write jobs in R, SQL, Python, Scala, Java in Azure Databricks. Now coming over to lesson number 2, provision Azure Databricks and Workspaces. So how do we create workspace? How do we create cluster and so on and so forth? So these are screenshots of that. We'll create the cluster in the pretty soon. So have a look at this. The first thing which we create is the workspace. Workspace is more like a wrapper around multiple clusters might be there. And the clusters can be of multiple type as well. We can have standard cluster, high concurrency cluster, single node cluster. Single node cluster means pseudo cluster, one node cluster for some testing purpose or maybe development purpose. Secondly is called a standard cluster. Default will be selected standard. Standard cluster means that single user cluster, one user can run jobs over there. However, in production, might be having a requirement that parallel jobs are running. So then we go for high concurrency cluster. So everything is part of one workspace where everything is, we can say what is workspace is more like a boundary where your entire solutions of Databricks will be there. This is the look and feel of how Databricks portal, and I'll show this to you shortly. And we'll click on the cluster option. We'll go to the cluster, create some cluster. We'll go to the workspace. We'll create some workspace over there. So in the workspace, basically we'll go and we'll create some notebooks over there. Now, just FYI, which notebook format is used in Databricks? The format is called as Databricks DBC. And which browsers are best to use with Databricks? Answer will be Chrome and Firefox. So go for it. Now coming over to lesson number 3, we'll talk about how Databricks access data resources and how do we read data with Azure Databricks. So we were already talking about that data can be loaded from Data Lake. So what is Cosmos database is basically global distributed database. So data can, whenever the solutions are global, we use Cosmos DB. In that particular sense, when streaming solutions with Event Hub, global solutions with Cosmos DB, and unstructured data will be stored in Data Lake. And the other options are relational solutions like SQL and Synapse. We can read data, we can write data, all of these various locations. Now, when we read data into Databricks, basically some of the syntax in SQL and Python is over here. So select column 1 from my column is equal to select data frame dot select column 1. Describe my table is equal to data frame dot print schema. Select star from my table where column is greater than 0 is equal to db dot filter column 1 is greater than 0. Group by and order by is equal to group by and order by in Python data frame functions are there. Where statement where column is greater than 1990 is equal to filter year column 3 greater than 1930. So you can say similar, same thing is there in different languages. And we can also display things in, you can say, basically text and HTML format as well. So how do you connect to Spark? So this is one FYI thing as such. How do you connect your Spark cluster to Azure Blob? So Azure Blob is part of storage account. So what do? We mount that particular location into Spark cluster. So when you mount something, it is available as a local file path. For example, if I mount one folder which is in your laptop into my laptop over the network, basically it will be visible inside my laptop as some slash folder path. Similarly, when we mount blob into Spark cluster, it is available as a local slash folder path. So it doesn't load data, but if you do any operation that go to this slash folder path and read the file called as, let's say, movie.csv, and the file really exists, then it will work exactly the way normally as if the data was locally there. It will work in the same manner because it's now mounted. That's how we do it. How does Spark connects to MySQL, Hive and other data store? FYI, the same answer. JDBC drivers are there. With that, we connect them. How do you specify parameters while reading data? We have a dot operator. We use dot option. That's particular function is there. By with this function, we pass the parameters in a parameterized script at runtime as key value pair. Dot options like that. Now coming over to lesson number 4. In lesson number 4, we'll talk about transformations with Azure Databricks. So the very first thing which comes to mind when transformation comes to mind will be ETL. And ETL is the first thing, basic transformations, and we'll talk about advanced transformation as well. Now as part of ETL, process, extraction, data validation, transformation, corrupt record handling, loading data is a normal various steps which are over there. Now, so when we talk about extraction, you can extract from Postgres, SQL, Cassandra, Cosmos. Formats can be CSV, Parquet. Data validation, when you're reading the data, whether the data which you read is, you can say we do a sort of validation of the data. Like, is the same data what you expected, or is this something else? So you can print it out. You can let's say cross check it with another data storage. That okay, is this data correct, or is it corrupted, or what? So if it is corrupted, we can do corrupt record handling. So missing data, incomplete information can be handled further. And then we transform the data. So you can transform data into desired format, desired structure, desired join, and join data frames and things like that. And one of the transformation, or when we work with loading of data, one of the optimization we do with whenever we are working with Spark is we transform the data into Parquet file. So Parquet file is write heavy, but once it is written, it is very optimized for read operation. Parquet file format, column family, you can say file format as such. And when we read from Parquet, it's pretty fast. And in data science or data engineering, writes will be less, reads will be more. So conversion of the data into Parquet or CSV or TSV file into Parquet format it provides very good optimization. We can also do normalization of values. Normalization of value, basically this concept is coming from data science. Now, when we do machine learning, there might be some columns which are having values which are very big. So mathematically, there can be two columns. One is having smaller values, one column is having bigger values. So the column which is having mathematically bigger values, it just by having that bigger number, it might be dominating the result of my model training. So we can do normalization. Normalization basically means rescaling of my data or standardization of my data. Basically reduce the dominance of one column on the entire model training. So it's not much relevant with our training right now, but just FYI, normalization is a normal machine learning step. Missing data and null value imputation or removal of missing data or replacement of it with mean, mode, median, or substitution of missing data with another type of value. These are some tasks which are part of basic transformation. Deduplication of data basically means that if I have the same file in two locations and they're exactly same, then how can we handle that? So so we might be able to store that once in the disk, but we might be representing it twice in both the locations. So deduplication needs to be handled. Otherwise, we are unnecessary wasting disk space for same file stored in for, you can say, in two different locations. We can also pivot the data frames. Pivot the data frame is like very similar to transpose a metric. So if you know what is transformation of a when we transpose the metric. So similar to that, we can also pivot the data frames. Now, part of advanced transformation, you can define your own user-defined functions. So whenever the default Apache built-in functions will not be of which are not, let's say, are not useful to you, you can write your own functions and you can use those functions. They are called as user-defined functions. We can also do joins and lookup. Now, two things I want to talk about over here. One is called as standard join. Second is called as broadcast join. So in standard join, moves all the data on the cluster for each table to a given node on the cluster. So data movement is, you can say, expensive operation. A lot of data movement happens. And what is broadcast join? Broadcast join, let's say you are joining two data frame 1 and 2. So data frame 1 is very big, 2 is very small. So instead of taking 1 to 2, take 2 to 1. So what we can do, the data frame which is sufficiently small can be duplicated on each node on the cluster and avoiding the cost of shuffling a bigger data frame. So this is called as broadcast join. And you can load, so loading transform data to multiple databases can be time consuming activity. Partition and slots are option to get optimized performance from database connection. A partition refers to the distribution of data, while a slot refers to distribution of computation. So partitioning and slot options are there, by which when we work with multiple databases, we use these options to reduce or optimize the operations. So from this page, you basically have to remember that we have user-defined functions. User-defined functions are, we need to create them whenever default functions are not useful to us. We have two types of join. Standard join, where normal movement of data happens, expensive operation. Second is called as broadcast join. Normal standard join is also called as shuffle join. So standard or shuffle join. The other one is called as broadcast join. And broadcast join, basically smaller data frame goes to bigger data frame. And the third thing you have to remember is that we have partitioning is possible and slot option is possible. Partitioning refers to distribution of data and slot refers to distribution of computation. So couple of questions over here. FYI, by default, how are corrupt record dealt with spark.read.json? We have, so one column will get created automatically called as corrupt record column. In that corrupt record column, we'll come to know which records are. They appear in a column called as, you can say, corrupt underscore record. So it handles it. It tells us that these are corrupt records. We want to do something with them. So what is the recommended storage format to use with Spark? You remember we just talked about it, that Parquet file format is the most recommended method. Why? Because Parquet is very optimized for read operation, and data engineering, data science, read operations will be more versus the write operation. And once we convert the file, it's we read it pretty quick, right? Millions and millions of rows can be loaded within seconds as such. So Apache Parquet is the file format. Column family is the one. So now let's go to the lab. Let's create one Databricks. Let's create the workspace. Let's create the cluster. We'll do some Azure Active Directory rights management, and then we'll do the end-to-end thing, right? So let's get started with the lab part.
We have put on everything about the certification and a lot more on this 12-week roadmap that we have created for you if you are preparing for Microsoft Azure Data Engineer Certification DP-203. On week number 1, we start with explore compute and storage options for data engineering workloads. Then on week 2, we cover run interactive queries using Azure Synapse Analytics serverless SQL pools. On week number 3, we cover data exploration and transformation in Azure Databricks. On week number 4, we cover explore, transform, and load data into data warehouse using Apache Spark. On week number 5, we cover ingest and load data into data warehouse. On week number 6, we cover transform data with Azure Data Factory or Azure Synapse pipelines. On week number 7, we cover orchestrate data movement and transformation in Azure Synapse pipelines. On week number 8, we cover end-to-end security with Azure Synapse Analytics. On week number 9, we cover support hybrid transactional analytical processing with Azure Synapse Link. On week number 10, we cover real-time stream processing with Stream Analytics. On week number 11, we cover create a stream processing solution with Event Hubs and Azure Databricks. By week 11, we are pretty confident that you are ready for the certification exam. So to top it all off, On week number 12, we help you with some tips and resources for clearing certification and CV preparation, along with some exam questions and interview questions. Guys, this is an excellent training program that we have created specially to meet your needs as you are preparing for the certification exam. If you are interested in this training program, then I would highly recommend you to go and attend our free class on Microsoft Azure Data Engineer Certification. In this free class, we will be covering what is Azure Data Engineer role and exam DP-203, why everyone is working on data currently, important Azure services you should learn, and there is going to be a live demo as well on Azure Synapse Analytics components. To register for this free class, go at K21Academy.com/AzureDE02, then select an event date, your name, your email ID, your phone number, and then click on Yes, Save My Seat. Once you click on this button, you will be redirected to this particular page. That means you have successfully registered for this free class. Now, guys, I'll see you guys directly at the free class.